So, as I often do, I went back through the lecture, just reviewing everything and making sure that I liked the way that I presented it. And I realized that I made a mistake on one of the problems. And I want to go through and show the mistake I made and do a couple more examples to really, hammer down how we're supposed to do this type of problem. So, when we go here to the reference angle, it says that it's an acute angle formed by the terminal side of theta and the x-axis, and this was the mistake that I made. So in example 1, if theta is 330 degrees, we go around 90, 180, 270, and then we go another 60. That's absolutely correct. The problem is that I said the reference angle is then 60 degrees because it's 60 from this y-axis to the terminal side. But if you look at the definition is the x-axis. So in fact, this is the terminal angle, and this is going to be 30. So I didn't follow the definition as closely as I should have. So that's the issue. So this 60 degrees is correct in the sense of, yes, you go 270 and then add an extra 60, but that's not actually the reference angle because the definition of the reference angle refers to the x-axis. So it's actually going to be this extra 30 degrees that you have. So we're going to say that this is now 30 degrees, and then it will be in quadrant 4. So that will actually work. So that's my fault. I apologize. It's from the x-axis, not from the y-axis. You can use the y-axis to see how far you need to keep going, just like we went an extra 60 degrees. But then when you're actually doing the reference angle, it is the x-axis. So that means example 2 is perfectly fine because this, we go around once, we go around twice, and then we go another pi over 4. And so then the reference angle is with respect to the x-axis, which in fact is just this pi over 4. So example 1, I made the mistake of drawing the reference angle from the y-axis when it should be from the x-axis, but example 2 is correct. So let's do a couple more examples just to hammer this point home. So 150 degrees. So again, we could always look at our unit circle for 150 degrees, or we can say, all right, I'm going to go 90 and then another 60, right? So I go 90, another 60. So this is like an extra 60 degrees, but remember the reference angle is from the x-axis, so that means that it's actually going to be this angle in here, and this angle is going to be 30 degrees. Another example would be negative 5 pi over 6. So for negative 5 pi over 6, we'll go ahead and draw our Cartesian coordinate system, and we're going to go, so this is pi over 2, which is 3 pi over 6, so 4 pi over 6, 5 pi over 6, and we went this direction. So then the reference angle is going to be from the x-axis, and in this case, it is just pi over 6. Because it's pi over 6 more to get to the x-axis, and then we need to be sure to have our quadrants here. So this was 30 degrees is the reference angle, but it is in quadrant 2, and this is pi over 6 degrees, but it is in quadrant 3. So that's how you use the reference angle. So I apologize. Just to reiterate again, the reference angle is from the x-axis. So you can use the y-axis to make sure you know how much further you need to go, as we did with going this extra 60. But then the reference angle is defined in terms of the x-axis itself. So then we would just need to figure out how much more we would need to get to the x-axis, and that's our reference angle. And then we need to make sure we know what quadrant we're in, because then we can switch around the sign, positive or negative for sine theta or cosine theta. Okay, I hope that makes sense. And if there are any questions, let me know.